All right, so if we consider this example here, this is example one, which is typically the homework, but in the homework I ask you to do position analysis. Let us consider the same mechanism, which is that you have a slider at slider A, and there is a connecting link, which is O4 B, and there is another crank. This is the crank O2A. And this angle is already given by 20 degrees. And the crank, which it should be O2A, this is the crank, it already rotates with a constant velocity of 30 radian per second, right? And it is required to do some calculation regarding the velocity, the acceleration of either the slider A or point B as already given there. So anyway, we weren't gonna do any velocity or acceleration analysis unless we do or finish the complete or the position analysis, then the velocity, then the acceleration. It means that we have to do the regular kinematic analysis of this mechanism. And it is typically like the same, as I said, this is the homework problem number 2. But in the homework, I ask you to do just position analysis. Here we're gonna work over this problem by doing a complete kinematic analysis, including the position, velocity, and acceleration. So I'm gonna start directly to this problem, and the first step is just to give numbers as usual to the different links that we already have. We agreed to have number 1 for the frame or the ground. The crank is gonna be number 2, and the link O4B is gonna be link number 3. Make sense? And we do have the slider is gonna take a number like number 4. Then your objective is just to set up some position vectors. So let us set up here over 1. This is gonna be like position 1, position vector 1. You can assume that it is already going up, going down. It doesn't matter because it is connected between two fixed points. And let us give it like R1. And definitely we're gonna have here R2 for the link or the crank. This is gonna be R2 vector. In addition, we're gonna have R3, and you should keep in mind in the beginning, I'm gonna consider that R3 is just set up between O4 and A. It won't gonna move to B. It means that I'm gonna, in the beginning, I'm gonna exclude this part. I'm just gonna consider that I do have this simple triangular shape, and this is gonna be R3. In the meanwhile, you should understand that R2, it works for the crank O24A, and R1, this is just a fixed frame, and R3, this works for both, for two things. Works for the length 3, which is O4B. In addition, it works for the slider. So it describes or it's related to the position or the motion of the slider in addition to the rotation of the length 3. So in general, we do have 3 position vectors, and our objective is just to set up or identify each one of these parameters in terms of R1, how much is R1, how much is theta 1, how much is R2, how much is theta 2 as usual, and R3 and theta 3. Make sense? So if I ask you how much is R1, it should be the distance between O2, O4, right? In the given problem here, R02, O4, this R02, O4 was given by 12 inches in the homework, and RaO2 was given by 7 inches, while the RbO4 was given by 28 inches. Make sense? So if I ask you how much is R1, it should be the distance, which it should be 12 inches. How much is theta 1? Theta 1, it should be 90 degrees. This should be theta 1, because you, from the start point, I assume that it's going up. From the start point, go to the right, give rotation counterclockwise. This is going to give us theta 1. Theta 1 in this case is going to be 90 degrees. And how about R2? R2 should be the length of the crank O2A, which is already given by 7 inches. And theta 2 should be this angle. If you draw a line to the right and give rotation counterclockwise, this is going to give us theta 2. Theta 2, as you can see, it's going to be the 290 and 90, yes, because it is 270 plus 20. So this is going to give us the 220 degrees. and R3 it should be the O2 O4 BA, which is this distance, and definitely this distance normally it will not be given because we don't know exactly what is the location of the slider with respect to either point B or point O4. So it means that R3 is unknown, and as well as you can see theta 3 it will be unknown as well, which it should be this angle, because this is I'm working over R3. So if you draw a line to the right, go counterclockwise, this should be the theta 3 angle. So as you can see that we do have two unknowns. Go ahead. Yeah, no problem, that's fine. Okay. So for R3 and theta 3, these are the two unknowns that we should have. This indicate that we're already working as case one, which is the simplest case. But you should understand in the meanwhile that this angle it should be located in the first quadrant according to the given configuration of this mechanism. In addition, we have to identify which one of these parameters is variable or varying over time, which one is constant over time. So if we're gonna look to the R1, it definitely it is constant because this distance won't gonna change. Theta 1 as well it is constant because this length R1 it won't gonna rotate. But R1 it is constant, R2 it is constant as well, but theta 2 it is variable because this length would rotate, and that's why it is already given an angular velocity of 30 radian per second, which is constant as already mentioned here, right? So theta 2, and let us assume that this omega is already going in this direction, like this is the omega 2 direction, right? So since the length rotates, this indicates that this theta 2 it should be variable, varying over time. R3 as well, it will be variable because this distance O4A is going to increase or decrease as the slider moves. It means that this one will be would be variable, and theta 3 as well, it should be variable since the length 3 will be rotating. Make sense? So these are for these parameters. Then your objective is just to do the position analysis as usual. So I'm gonna start with the position analysis for, go ahead. Because the length O4B is going to rotate. اللينك O4 هو متثبت عند O4. اللينك O4B اللينك كله متثبت عند O4. لما تيجي تحرك الكرانك اللي هو لينك 2 تدي له حركه للسلايدر هيبدا يتحرك، فمع حركه السلايدر هياخد روتيشن. اللينك O4B هياخد روتيشن شويه. يعني لو انا رسمت لك كونفجريشن تاني بعدها بشويه، يعني نفترض ان this is another configuration. assume that the link has been rotated. اللينك 2 هيلف كده لغايه هنا، فهتلاقي السلايدر طلع كده. فالسلايدر عشان يطلع ديفينتلي لازم الايه اللينك ده ياخد روتيشن. Make sense? So we do have for this case R3 it is completely variable in terms of direction and magnitude. Theta R3 and theta 3 both are variable for this length 3 and the slider as well. Make sense? Okay. All right, so now let us move to the position analysis. The first step is just to write the loop closure equation of the position. For the position analysis, we have three vectors. Position vector R1 is going in the same direction as R2, but R3 going in the opposite direction, right? So what does it mean? It means that you're going to have R1 vector plus R2 vector. It should equal to the R3 vector as already given there. And as based on this data, you're gonna see that R1 is already completely defined, fully defined, R2 fully defined, but except R3 it is fully unknown. It means that this should be case 1, right? Which is the simplest case. Then the next step is just to rewrite again this equation in terms of the exponential form. So this is gonna be R1 EI theta 1 plus R2 EI theta 2 equals R3 EI theta 3. Then I told you in case that you do have an angle theta that is constant and there is a common angle like 0, 90, 270, whatever, like 180, substitute directly with this angle as long as it is constant. But if it is variable, don't substitute with the value of the angle. Make sense? So for example, for this case, I do have theta 1 equals 90 degree, which is a common angle. In addition, it is constant. So I can substitute for theta 1 equals 90. If we substitute for theta 1 equals 90, this term will reduce to IR1 as we demonstrated before. If you just decompose this one into cosine and sine term, the cosine of 90 is 0, but the sine of the 90 equals 1. So this is going to give us IR1. Make sense? This term. And just carry on the other terms. Theta 2 equals R3 IEI R3 theta 3. This is going to give us the first equation that should be differentiated after that for the velocity and the acceleration analysis. Make sense? Now your objective to complete the position analysis is just to collect the imaginary and the real terms. The real term, this term definitely it is imaginary term, so I'm gonna skip this term. The real term of this RE I theta, it should be the cosine of theta 2, right? But it should be multiplied times R2. The real term of this part, it should be R3 cosine theta 3, and this is gonna give us the first equation A. From the imaginary term, this term is imaginary, so this is gonna give us R1 plus the imaginary of this term, it should take the sine of theta 2. The imaginary of this term, it should take the sine of theta 3, and this is gonna give us the second equation, equation B. Then as usual, based on case 1, if you divided equation B over equation A, this is gonna give us this right hand term, but you have to isolate this unknown vector in one side. This is gonna give us the tangent of theta 3. It should equal to the how much, if you sine, it's gonna be sine over the cosine, so it's gonna be R1 plus R2 sine theta 2 over R2 the cosine of theta 2. We do have everything except theta 3. So R2 is already given up there by 7 inches. This is 7 inches. This one is given by R1 by 12. R2 is 7 inches. Theta 2 is already given. We got it by 290, 290. So if we did the calculation, we shall end up with a value for theta 3. Then by substituting into either equation A or B, we're going to end up with R3, right? Is there anyone solve this problem? And how much is the theta 3 if you have your notes? Or it doesn't matter. You're going to get a value for theta 3, get a value for R3. Make sure that theta 3 should be located in the first quadrant as we indicated here. And that's it for the position analysis. Make sense? Then you're going to move to the velocity analysis, which is going to be the second step. Okay. So for the velocity analysis, we're going to work again over this equation, which is this one, equation 1. So I'm going to copy this equation here. It should be I1, I, R1 plus R2, EI, theta, EI, theta 2 equals R3, EI, theta 3. Make sense? So this is the first equation. I'm going to differentiate this equation with respect to the time to end up with the loop closure equation, but for the velocity analysis. So this term, R1 is definitely constant as already given there, right? All the terms are constant except 3, which are theta 2 is variable, R3 is variable, theta 3 is variable. So if we just indicate it here, this one is constant, this one is constant, this one is variable, this one is variable, this theta is variable, right? So we're going to do the differentiation. The derivative of R1 definitely is going to be 0. So we'd have 0 term plus the R2 is just constant. And the differentiation of, or the derivative of the exponential term for theta 2, it's going to give us theta 2 dot EI theta 2 plus pi over 2 as we agreed before, right? equals, this one will be, we do have two variables, so we're gonna fix one like R3, then we're gonna do the derivative with respect to theta 3, so it's gonna give us theta 3 dot EI theta 3 plus pi over 2, plus I'm gonna do the derivative over R3, so it's gonna be R3 dot EI theta 3, and this is gonna give us the second equation, which it should be the equation for the velocity analysis. This is equation 2. Make sense? In the meanwhile, before you move further, let us investigate the directions of these components of the velocity, right? So the first term, which is R2, it means that it belongs to this length R2. And as you can see, the length R2 here is just giving rotation. So for any length that rotates, like for example, it has 2 points, point A and O2. It means that this velocity vector, it identifies this one, this component, it gives the velocity of point A with respect to O2 that belong to the length 2, and its direction is perpendicular to R2 and follow the direction of theta 2 dot, which it should be omega 2. This is how we can read the directions. So what does it mean? It means that this term, it should be perpendicular to the R2 vector follow the omega 2 direction, right? And omega 2 as given there, it is already rotating in the clockwise or counterclockwise direction. It means that the velocity of point A, it should be perpendicular to R2 going in the same direction of omega 2. Make sense? So this is for the first term. The second term, both belong to the R3. It means that they are related to this position vector R3. And this position vector, as we mentioned in the beginning, that it is related to two things, the length 3 in addition to the slider, right? So that's why it has two components, because it describes two velocities, one for the slider, one for the length. The velocity of the length is like a length that rotates. The velocity of the slider, that it is like a slider that moves, object that do translation and motion. So that's why before we said that point A should have like two virtual points located at point A. Point A, like it is located over the length, point A that it is like located over the slider itself. So generally we're gonna say that we do have two velocities here. This first velocity, which is R omega, because this is theta dot, this should be the velocity of point A, but with respect to O4 vector, which it should be the velocity of point A, and this should be the velocity of point A as well. But this A, it is A like belongs to the crank, and this A like A belongs to the length 3, right? And definitely they should have the same values. Anyway, this one, it should be perpendicular to the R3 vector, and it should follow the direction of omega 3, which we don't know omega 3 how much it is so far. But this one, it should be the sliding velocity. This is Vs, where S stands for the sliding velocity, that it should be in the same phase. This one was perpendicular, pi over 2, but this one, it should be in the same phase. So it should be parallel to the R3 vector. Parallel, it means that it would be in the same direction or the opposite direction, it depends. Make sense? Then what you're gonna do is simply, you're gonna work over the dot terms. We do have three terms that include dot, which are the R dot 3, and we do have theta 3 dot in addition to theta 2 dot. Which one of these three should be given? At least one should be given, and you can solve this equation for only two unknowns. It means that at least I should have one of these three. This one, it should be omega 2, which is theta 2 dot, that is already given up there by 30 radian per second. He mentioned that this one was given by 30 radian per second. This is the constant velocity of the crank, and the crank is definitely O2A. So it is, this omega was given by 30 radian per second, and the direction as represented over the drawing here, it is counterclockwise direction. We mentioned that in case that it is counterclockwise, so it should be positive. So it means that it's gonna be positive 30 radian per second. This is the omega 2, right? And these definitely will be unknown. In addition, he mentioned up there that this omega 2, it is constant, and since we have no clue how much the values of R3 dot, theta 3 dot, even their values, whether they are constant or variable, we have to consider them variables. So these are the parameters, and now we have to solve this equation for these two parameters, these two variables. To do so, we have to collect the real terms and the imaginary term. So let us start with the real term. The first term definitely is 0. The second term, the real term, it should be R2 theta 2 dot cosine theta 2 plus pi over 2. But we agreed that the cosine theta 2 plus pi over 2 gives negative sine theta 2. This is equivalent to get rid of the pi over 2. We can write this one as negative sine theta 2. This is the equivalent to this term, equals R3 theta 3 dot the cosine of theta 3 plus pi over 2 gives negative sine theta 3 plus the R3 dot the real part of this one is just cosine theta 3 and the cosine theta 3 is just cosine theta 3. So this is going to give us the equation A, and the imaginary part, which it should be the sine of this one. So it's going to be the R2 theta 2 dot sine theta 2 plus pi over 2. We mentioned that sine theta plus pi over 2, this gives cosine theta 2, positive cosine theta 2. So I can write this one to get rid of the pi over 2 to be positive cosine theta 2 equals the R3 theta 3 dot, again sine theta 3 plus pi over 2 gives positive cosine theta 3 plus the R3 sine theta 3. This is going to be the imaginary term of this part, and this is going to give us the second equation, equation B. As you can see, I wrote the real and imaginary equation directly. If you would be confused, do it step by step. You can just decompose this one into cosine and sine. Then you're gonna write the real, collect the real terms, then collect the imaginary terms, then convert the cosine theta plus pi over 2, which should equal to the negative sine theta, and so on, right? Till you're gonna end up with these two simple equations. Now we have two equations and just two unknowns. These two unknowns are R3 dot theta 3 dot. We do have everything except these theta dots and R3 dot. So for example, R2 was given by 7 inches. Theta 2 is already given by positive 30 radian per second. Why positive? Because it is counterclockwise direction. But if omega 2 was given, if it was given by in clockwise direction, it should be negative 30. But here it should be positive 30 as long as it is given in the counterclockwise direction. Theta 2 will get it by 290. R3 is already given, we already got it. We should get this one from the position analysis. We should get the this one in inches, R3, and theta 3, it should be the omega. This is the one of the unknown. Theta 3 is already we shall get this one here, theta 3 dot, and so on. So we got this one. This one is the second unknown, and this is the second unknown, and the same thing, we do have everything in this one here. This one is unknown, this one is unknown, this theta is already, we got it, this is 290, and this one is positive 30, this is 7. So solving equations A and B, we shall find value for R3 dot. And you should understand that this R3 dot, it should be the sliding velocity of the slider, and theta 3 dot, we're gonna get it, which it should be omega 3. In case that we have there are two possibilities here. Anything that is already positive and negative. In case that the R3 dot, it is positive, it means that for R3 dot, if it is positive, it means that it is in the same direction, the same direction of R3 vector. Make sense? But in case that it is negative, so it should be opposite direction of R3 vector. This is in case that R3 dot is already positive or negative. For theta 3, if it is positive, this indicates that it should be counterclockwise direction. If it is negative, it should be clockwise direction. This depends on the value that you're gonna get here, whatever it is, positive or negative. Make sense? So this is for the velocity analysis for this part. They didn't want to have any questions so far. Okay. So now we're gonna move to the acceleration analysis, which is gonna be similar, just acceleration analysis. So for the acceleration analysis, we're gonna work over this second equation here, which is this one. So we have three terms. The first term, it is R2 is constant, right? Theta 2 dot, he mentioned there is constant angular velocity. It means that there is no differentiation for theta 2 to be theta 2 double dot. It means there is no alpha, but this theta 2 is already variable. So it means that for the derivative of this first term, we do have only one term here. It means that we're gonna have R2 theta 2 dot square EI theta 2 plus pi over 2 plus pi over 2. This gives integral pi. This is the derivative of the first term. Make sense? We have like theta 2, so this one became theta 2 dot square, and we added one more pi over 2 to the pi over 2. How about this term? It has three variables. It has R3, theta 3 is variable, theta 3 dot variable, theta 3 is variable. This one also are variables. So we're gonna end up here with three components of the acceleration in total. We're gonna end up with R3 theta 3 dot square EI theta 3 plus pi plus the R3 theta 3 double dot EI theta 3 plus pi over 2 plus, we're gonna end up with four components, and we do have the 2R3 dot 3 theta 3 dot EI theta 3 plus pi over 2. This should be theta 3. And we do have the R3 double dot EI theta 3. So this is gonna give us the third equation, which is for the acceleration analysis. As you can see, this R3 thing, it has been expanded over four terms. It means that we have four components of the acceleration. This one definitely is a normal acceleration, which is R theta dot square. This one is a tangential acceleration, which is R times alpha. And this one is a sliding acceleration. This is the sliding acceleration of the slider itself. And this one is the Carriolus acceleration, which is ACR vector. The Carriolus acceleration is a new component that we just discussed in this course. And as you can see, the direction of this one, it should be perpendicular to the R dot. R dot, this should be the sliding velocity. So it should be perpendicular to the sliding velocity. Follows the omega 3. It should follow the direction of omega 3 that we shall find its value before in the velocity analysis. So we're gonna end up with this equation. Then if you just decompose this equation into real and imaginary terms, you're gonna end up with very similar two equations to these two equations in just two unknowns. These two unknowns will be R double dot, the unknowns here are R3 double dot in addition to theta 3 double dot. Just after decomposing or collecting the real terms of this equation and the imaginary terms, you're just gonna end up with just two equations and just two unknowns. Solving these two equations for the two unknowns, you already done of this problem. Make sense? Then your objective is just, so by finding this R3 double dot and theta 3 double dot, we completed the kinematic analysis. Then your objective is just to go over the requirement. What is already required and what are the things that you got. If there are some information that you have to work more over it, like for example, the velocity and the acceleration of point B, what we did does not give us the velocity or the acceleration of point B. We have to do further. We have to work more. It means that we have to set up a position vector for the for point B, and that is fine to refer to point 04. It means that you're just gonna have one R, differentiate this R once and two times to find the velocity and the acceleration of point B, as we did before in the previous meetings. Make sense? So this is there any question so far? So this is for this example. How about this one? This is known as a Scotch yoke mechanism. This mechanism has crank 2, which is this crank, O2A. Crank generally in mechanisms, as we mentioned before, that we should set up here like a motor, like an electrical motor. This electrical motor is gonna give 360-degree rotation for this crank. This crank is gonna keep rotating, and something is gonna happen to the other link that is connected to the crank. So the crank 2 is driven at 36 radian per second counterclockwise, and it is constant. So radian per second, this definitely should be angular velocity, right? And its direction, it is counterclockwise direction as already represented here. So this should be omega 2. And it is constant. It means that there is no alpha 2. Alpha 2 is already 0. Do a complete kinematic analysis of the mechanism using the complex algebraic method, right? But if we're gonna look to this mechanism, we do have the crank, and we can understand what does it mean crank, and we do have the slider, which is this element 3, right? And there is something new here, which is just this thing, this slot. This is like an internal slot, and the slider can freely slide inside this slot, and we do have a link that also slides over this another slot here. But all of this object is just a single object, a single part moving together. All of this object is just one single link. Make sense? And how did we know this? Because there is a welding here. This portion here, this part, it is welded together. This indicates that all of this is just a single object. So there is welding here in this portion. This is welded. Make sense? So in total, we do have 4 objects. We do have definitely the frame, which is the ground, any link, any fixed parts, the pieces, these are the grounds. And we do have the crank, which is element 2, and we do have element 3, which is the slider, and element 4, which is this weird or special shaped link. Make sense? So we do have these objects, and the distance O2A is already given by 50 millimeters. In addition to omega 2 is already given. Go ahead. Go ahead. Do you have a question? Yeah, we're gonna deal with it like a link, as I'm gonna show you now. Okay, so don't be scared of the mechanism. Just stick to the procedure, the way of thinking that we used to do. The first step, what was the first step? Is just to give number to the different components. We give number to the different components. We have 1, 2, 3, and 4, right? Then what next? Your objective is just to set up some position vector to end up with a loop, a closed loop, right? So in the beginning, we should have here, this should be link R2, right? Should be vector R2, position vector R2. Make sense? For any regular link that rotates. In addition, we do have a slider. So we said that we have to set up R in the same way or over the line of sliding of the slider. The slider slides over this line, right? So there should be R over this line, and this R, it should be going to the slider as we agreed. So let us give this one like R4 or R3 or whatever. Let us give it name like R3 vector. Make sense? We do have another slider, and this is the thing that you should understand, which is this slider. This link, do you see this link? It moves right and left as we give rotation to the link. It means that this object is gonna keep going right and left. This slider is gonna keep going right and left. This slider A is gonna go up and down. So it means that here we would have 2 sliders, not just one slider. This one, which is the conventional shape of the slider as we understand it before, but this one is a new one, which is like something that is slot, that like you have a link, slides inside an opening or inside a hole that moves right and left. It means that we would have another R that should be set up here for this slider over the sliding motion. It moves right and left. So we have another R that we can give it like R1, and it should be going to the slider. This R1, it should be going to the slider as we agreed. So we're going to end up with a closed loop. This closed loop has three edges, three vectors as already given here. You got it? So I can represent this, all of this, it will be represented as follows. Like we're gonna have R2 vector, which it should be this R2, and parallel to the sliding motion, over the sliding motion of the slider, we'd have R3, right? So we'd have here from this point R3, which should be going to the slider. R3 should be going to the slider. In addition, we do have R1, and you should understand that this R1, it works, this R1 going to the other slider, because we do have here another slider. There is a slider here, and there is another slider here. Make sense? And you should understand that R2, it works for the link O2A, R3, it works for the slider, R1 works for this slider. Understood? Then your objective is just to work as usual. What was the first step? Is just to set up how, find R1, find R2, find R3, which one of them is constant, which is variable. So as for R1, it should be the distance between O2 to any point. Let us give a name here to this point, because for example, let me represent the loop here again. This is like R2 vector, and we do have here R1 vector, and there should be here R3 vector in this way. So we can give a name to this point like point O, whatever, or just without any name, it doesn't matter, right? Like this is the intersection of these two position vectors. So do we have the distance from O2 to O? No, this distance is variable and there is not given. The only distance that is given is O2A. It means that the only R that we have is just R2. We have only R2 is given by 50 millimeters, but these two are unknowns. Make sense? Which it should be the R1, this distance, and R3, how much is O to C? We have no clue. How about theta 1? Theta 1, it should be 0. Why? Because this slider, it moves over the horizontal direction, right and left. It won't gonna rotate, and the direction it goes to the right, it means that this angle is already 0 degree. And theta 2 is already given by 45 degree, because if you got move from the start point, move to the right, rotate counterclockwise direction, this is gonna give us 45 degrees. How about theta 3? Theta 3, it should be this angle. Theta 3, it should be this angle. From the start point, rotate counterclockwise, this should be theta 3. Make sense? Do you think that we don't have a value for theta 3? Anyone? Yes, it is 105, it is already given, right? And as you can see, we should know all the thetas, because we don't have only unknowns. We are confined to only two unknowns. We cannot do position analysis with more than two unknowns. So we have two unknowns. It means that all of these thetas should be given, and it is definitely given by 105. Go ahead, Mohammed. Right, so theta 3 is already 105, or is already given there. So it is 105 degree. Make sense? So simply, you're just gonna set up the loop and investigate the magnitudes of these position vectors in addition to the angles as usual. Then what? What is the next? Your objective is just to define which one is constant, which one is variable. Make sense? So if I ask you about R1, is it constant or variable? It should be variable, right? Variable, because it slides. R2, it should be constant, right? Which is O2A, it is a fixed length. I mean rotating length with a fixed length, right? So R2 is constant. R3, Variable, because the slider goes up or down, so this R3 is going to increase or decrease, so it should be variable, right? How about theta 1? Constant. Why? Yeah, constant. Why? The length it will not rotate. How about theta 2? It will be variable because the length is going to rotate. How about theta 3? Constant. Constant. Constant because it is welded. Do you see the welding here? Yeah, so what does it mean? Yeah, the movement of the slider is gonna produce a movement to the other slider. But it is not necessary for R3 to rotate. In this case, because it is welded, R3, it will not rotate. But how about if there is no welding here, if it is just a joint? If it is a joint, R3 will be variable, theta 3 will be variable. Go ahead. Between R2 and R3 will it change? No. Yeah, it is gonna change. This angle it will change. This angle it will change, but this one not. Yes, this link R3 it moves back in the same orientation. It is like you're gonna draw another. For example, let us assume that based on this direction of rotation of omega 2, this link will be shortened. It means or increase the length. The length of R3 will increase somehow because you give rotation, and it will be this. It will be moving in this direction and هتحرك شمال to the left with this parallel. These two lines are parallel without rotation. Slider A. R1 will be shortened فلذلك بنقول R1 is variable. وR3 هتزيد. R3 طولها هيزيد لذلك بنقول R3 variable. ولكن الخط ده R3 هيتحرك زي ما هو هيزيد طوله بس الزاوية مش هتتغير هتحرك. ايوه كل اللينك الغريب ده كله على بعضه بيتحرك right or left right or left right or left and that's it. So that's why we said that theta 3 should be constant because of the welding here. But if there is a joint يعني لو معاك نفس المسألة وحط لك هنا joint ده معناه ان theta 3 is variable. Go ahead. هو ده الجزء الجسم ده كله ده الجسم ده كله ده كده حتة واحدة جسم واحد ماشي. الجسم ده كله قطعة واحدة. القطعة دي هتتحرك كلها على بعضها كده شمال أو يمين. ما هم ملحومين في بعض يعني ده قطعة واحدة اعتبر بار واحد كده. ده كله بار واحد ده كله جسم واحد ده كله جسم واحد مع بعض. ده كل الجسم ده بقى يتحرك ايه going left or right left or right. فبالتالي الزاوية دي بقى هنا لما كلهم يبقوا جسم واحد الزاوية دي استحالة تتغير. ويتحرك في نفس الوقت. انما بقى لو جينا هنا بقى شلنا اللحام هو قال انه ولدد من المنطقة دي ملحوم مع بعض قطعة واحدة. انما لو جينا بقى حط لك هنا جوينت فجوينت مين there is no welding فده معناه ان ده حر بالنسبه لده فساعتها يبقى احنا هنا بنتعامل مع جسمين مش مع جسم واحد. ده جسم وده يبقى جسم اخر. فهمتني؟ الجسم ده بقى الجسم ده اللي هو البنفسجي ده البيربل ده هيبدأ يلف ويمشي مع مين مع ده. انما الاخضر ده بس فقط لا غير بيتحرك. ده لو كان جوينت. هنا ما عندناش الحالة دي وده طبعا بالنسبة لنا في الحل سواء ويلدد أو جوينت البروسيجر ثابت. الاختلاف كله ما بين الحالتين البداية دي، مين هيبقى فاريبل مين هيبقى كونست. الاختلاف انك هتحط دي فاريبل وتكمل المسألة عادي. مش فاهم. لا على حسب ده، هو ده كده على حسب بتختلف. افترضنا معاك 4 بار لينكج، في لينكات، في ميكانيزمات فيها 7 و8 لينكات، يعني تلاقي فيها 7 8 بوزيشن فيكتورز، فبتختلف بقى من مسألة للتانية. Make sense? So this is for this start. And once we set up these R's and thetas and know which is constant, which is variable, the rest of the procedure is the same, typically identical the same. يعني انت في النهاية بمجرد ما بتكون الحاجات دي انسى المسألة دي خالص، بقى معاك لوب كلوجر ايكويشن اهي، هو ده اللي انت تشتغل عليه. معايا 3 لوبس وادي المواصفات بتاعتهم، انسى المسألة وروح بقى اشتغل بوزيشن اناليسيس، فيلوسيتي اناليسيس، اكسلريشن اناليسيس، ورص الرصة اللي احنا بنرصها كل مرة. Make sense? So if we moved to the position analysis, I'm just gonna write the 3 equations because of the time. I'm just gonna write the 3 equations for the position, for the velocity and acceleration analysis, and you know the procedure. صح؟ يعني لو كتبت لك الثلاث معادلات الاختلاف الدنيا مش هتختلف بقى معانا. انت كل اللي انت بتعمله بتفصل ريال وتفصل ايماجينري وتروح تحل المعادلات تطلع المجاهيل، يبقى كده خلصت. Make sense? So for the position analysis, this one we do have R2, R1 and R3 going in the same direction, R2 in opposite direction. So we're gonna have R1 vector plus R3 vector equals R2 vector. Make sense? Based on this given data, we do have the R1 is fully R1 it has the magnitude is unknown, the direction is known, and the R2 is fully defined, but R3 it has also the unknown direction, magnitude, and the direction is given, right? Then our objective is just to decompose this equation into R1 EI theta 1 plus R3 EI theta 3 equals R2 EI theta 2. And as I said, that is fine to substitute with this angle, which is 0 degree, because it is constant here. So we're gonna end up with R1 plus R3 EI theta 3 equals R2 EI theta 2. This is gonna give us the first equation for the position. Then you're gonna decompose this one or collect real and imaginary terms to complete the position analysis. For the velocity analysis, analysis of this equation, so we do have here, based on this given data, we do have only 3 variables, which are R1, R3, and theta 2. So R1 is variable, and R3 is variable, and theta 2 is variable. But this one is constant, this one is constant, right? So if we did the derivative with respect to the time, this is gonna give us R1 dot, and that's it, plus R3 is variable, but theta 3 is constant. So this term, there is no derivative to this term. Why? Theta 3 is constant. But if there was a joint here, theta 3 will be variable. So it will have a derivative here. But this one has no derivative because it is constant. So I'm just gonna have EI theta 3 just constant, and R3 will be R3 dot. Very simple. Make sense? Equals R2 is constant. Theta 2 is variable, so it's going to be theta 2 dot EI theta 2 plus pi over 2. Make sense? If we decided to investigate these terms, this should give us sliding velocity, right? And this should give us also another sliding velocity. So that's why I mentioned here that we do have 2 sliders. Each one will have a sliding velocity. So for example, R1 dot, it should be the sliding velocity of this slider 4. But R3 dot, it should be the sliding velocity of the slider C or A of this slider. Make sense? So that's why we would have 2 sliding velocities here. But they are different. This is like for point This is for slider 4, but this is for slider A. And we do have one linear velocity due to rotation. This is R omega that is perpendicular to R2. This is the VA relative to O2 vector, which is that belong to the R2. R2 gives rotation, so it is the rotation of point C or point A with respect to O2. So this is the VA relative to O2 vector that it should be perpendicular to the R2 vector. Follow the direction of R2 vector. But this one is parallel to R3 vector. This one is parallel to R1 vector. Make sense? This is for the velocity. For the acceleration, we're gonna do one more derivative for this one. This is the acceleration analysis. For the acceleration analysis of this equation, this R1, we do have in this equation 3 dots, R1 dot and R3 dots, in addition to theta 2 dot. Theta 2 dot is already given as omega 2 and it was given constant, right? With a value up there. But these two are variable and unknown. This is variable, this is variable. So if we did derivative here, R1 is variable, it means that it should have R1 double dot. So we're gonna have R1 double dot plus R3 is variable, theta 3 is constant. So EI theta 3 will be constant. This is gonna give us R3 double dot only equals R2 is constant, but theta 2 dot also is constant. He mentioned that theta 2 is the only variable. So we're gonna end up with R2 theta 2 dot square times EI theta 2 plus pi over 2. This is gonna give us the third equation for the acceleration analysis. And again, it is just 3 components. It means that this component, it should be sliding acceleration, R double dot. This R double dot also sliding acceleration. But this is for point A, this is for point 4, for the slider 4. This is the normal acceleration of point A with respect to O2 vector that it should be. This should be pi, not pi over 2. Okay? Make sense? So this is the normal. These are the 3 acceleration components that even you can decompose this equation into cosine and sine and correlate the real parts and the imaginary terms and finish the acceleration analysis by solving these 2 equations in 2 unknowns. We do have R1 double dot and R3 double dot, which shall be the 2 unknowns for this mechanism. Make sense? The last mechanism here, I'm just gonna do the same very quick. I'm just gonna set up the position, the loop closure, then the rest of the procedure it is fixed. So as you can see, based on the previous examples and even the previous videos, the difference from one problem to the other problem is the beginning. If the position vectors, the loop that you're gonna set up and specify which one of these of the R's is variable, which one of the thetas is variable, which R of the R's constant, which R of the thetas are constants. Once you set up the beginning of the problem, the rest of the procedure is fixed to any other problem, whatever it is. So the key idea of this method, of the complex algebraic method, that we already converting the real problem into a simple loop, and we just solve this loop. Make sense? Once you convert it correctly, the rest of the procedure is the same. Stick to the procedure, it will be easy. So just the beginning of the problem. Make sense? Okay? Okay, I got it. So for this link, these are 2 slotted links. 2 and 3 are driven independently. What does it mean independently? It means that each one of these 2 links will be operating with 2 different electrical motors. So what does it mean? For this mechanism, it is a special mechanism. All the previous mechanisms that we discussed, like this one, for example, like this mechanism, only one motor can be used for moving the mechanism. يعني احنا في النهاية في الميكانيزم ده مثلا هتروح تركب موتور هنا، الموتور ده هيلف، هيدي دوران للكرانك، الكرانك ده يفضل يلف 360 درجة، تلاقي الايه الميكانيزم عمال شغال. فبنقول ان ده كانه ايه؟ كانه single degree of freedom system يعني. اوكي. هنا but for this one it requires two inputs. There is a special mechanism and this is a special type of problem, but anyway we're gonna discuss this type of problem in after the graphical method. For this mechanism it requires two electrical motors. One electrical motor is gonna work here to give rotation to this link, and another electrical motor that is gonna give another rotation to the other link. So what does it mean? It means that this link would rotate clockwise or counterclockwise. This one, it would be rotating clockwise or counterclockwise. So two opposite directions or even the same directions of rotation, they are totally independent. Make sense? So they are independently rotating at constant angular velocities of 30 radians per second clockwise direction and 20 radians per second clockwise direction as well, respectively. It means that link 2, which is this one, it rotates, this one rotates clockwise direction with omega 2, which is already given by the 30 radians per second, and this one rotates as well clockwise direction. Clockwise direction, it should be this direction, right? This should be omega 3, and it is already given by the 20 radians per second, also clockwise direction. Make sense? It is required to make a complete velocity analysis of the mechanism, or you would be required to calculate the velocity or the acceleration of point P, whatever it is. Forget about the requirement, just take to the procedure. So what was the first step is just to give numbers to the different links. We do have the frame, which is the ground, link 1, and we already have here link 2 and link 3. These are the three links or the three objects that we do have. In addition, that you should understand that point P itself, it is a slider, so that's why it has number 4. Point P itself, it is like a slider. It is a pin or a slider. I can represent point P like a slider, but it's gonna be like dual slider. What does it mean, dual slider? Like two sliders together in this way. Like one slider goes in this direction and there is another slider here at the same point. So it can slide over this direction, over this link, and also it can slide over this direction, which is over the link 2. Make sense? It doesn't matter even if you didn't realize that this P, it should be slider. Generally, we do have three links. So the next step is just to set up position vectors for all of these objects, right? So the first link, which is link 2, definitely it should have R2. In this way, that it should be projected out of the fixed point. So there should be R2 vector. Agree? And in addition, I should have R3, that it should be projected from the link, from the fixed point. This should be R3 vector. Make sense? So at the end, I got just two position vectors. And I didn't get any closed loop. How we can close this loop? You're gonna drop down here. You'd have two options, either to connect these 2 points together. So you're gonna end up with 3 loop vectors, right? But this position vector, you have no clue about it, right? So you have to set up, you can find the data of this one using the trigonometric relations from this 90-degree triangular shape, or the easiest way, and this is what we usually do, you're just gonna set up 2 position vectors here to close the loop. I'm gonna consider one position vector like R1 vector, and let us assume this is like R2 vector, R4 vector, for example. So at the end, we're gonna end up with a loop like this one from point A. Assume that this is point A, and we do have here point P, right? This is gonna be the first position vector, which is R2, and we do have another position vector where this should be point B, and we do have BP as R3 vector, and we do have the R4 and R1. The angle between them is 90 degrees, where this should be like R1 vector and this should be R4 vector. For R1, it doesn't matter whatever it goes up or down. It means that I'm assuming that there is a virtual point here like point O, and R4 goes right or left, it doesn't matter. But R3 it is better to be projected from the fixed point going to the slider. You should understand that this point B is a slider. So what does it mean point B is a slider? It means that R3, it has two functions. It works for the link 3, in addition it works for the slider. So the derivative of R3, it should give us velocity to the link and velocity to the slider B that it belongs to this slotted link, this one. The same thing for R2. R2 has two functions, works for the link 2, in addition it works as well for the slider B. So as you can see, point B, it is common between 4 different objects. Point B, it belongs to the length 3. Point B as well, it belongs to the length 2. Point B, it belongs to the slider. But this slider, as we mentioned, it is like dual slider in this way. So at point B, there are like 2 sliders. One slider that already sliding over length 3, another sliding that is already sliding over length 2. This is just, I'm explaining to you what is this mechanism, how it works. But even if you didn't understand using this method, how it works completely, at least you should define which one of these R's is variable, which one of these R's is constant. So this is the loop closure equation, or this is the loop for this mechanism, and these are the different position vectors that we're gonna use. Now we have to set up which one of these is constant, which one is variable. And we do have here theta 1, theta 2, and theta 3, and theta 4. Make sense? So for R1, is it, how much it is? It should be 25 millimeter. It is already given by 25 millimeter. And how much is R2? R2 should be the distance between A to P. This distance is not given. And in many of the cases, it will not be given. Why? Because R2 is variable. It's going to increase or decrease as the mechanism moves. So it means that R2 is unknown. How about R3? R3, it should be the distance between B to P. So it should be also unknown. We have no clue how much is this distance. So it is already unknown. How much is R4? R4, it should be the distance between point O to point B, which is already given by 100 millimeter, so it is already given, millimeter. So as you can see, we already collected the 2 unknowns. So it means that all of these angles should be given. And that's why this theta 1, it should be 90 degree, because it is 90 degree already. And theta 2, it should be this angle, which is 60 degree. This is R2. From the beginning, if you draw a line to the right, rotate counterclockwise, this is going to give us 60. So this should be 60 degrees. Theta 3, it should be from point B going to the right, rotate counterclockwise, this is going to give us theta 3, which it should be 135 degrees. It is already given. So as you can see in this problem, this is the first problem that we considered so far, and 2 angles are given. يعني ده أول مرة نشوف مسألة يبقى فيها 2 angles already given. Why? Because this is 2 degree of freedom system. These 2 lengths work independently. So that's why he gave us 2 angles. So we can proceed. Make sense? Theta 4 is already 0 because it is a horizontal going to the right. Which one of these R's and thetas are variable? Which one is constant? R1 definitely it is constant, which is this vertical distance. It won't gonna change. It is between 2 fixed points. R2, it should be variable. Why? Because if you give rotation to the length 3, this point is going to be moved up through inside the link. It means that R3 is going to increase. R2, I'm sorry, is going to increase. So R2 will be variable. The same thing applies for R3. R3, if you give rotation to length 2 in this direction, or even going down, so this point is gonna move down or up inside the slider 3. So this indicates that R3 itself is going to increase or decrease. It means that it should be variable as well. Make sense? So R3 is variable. How about R4? R4 is a fixed, is a constant distance between 2 points, 2 fixed points, which are point O and point B. So R4 itself, it is all the time 100 millimeter. It won't gonna change, so it is constant. How about theta 1? Theta 1 as well, it is constant. Why? This angle all the time it is 90 degree. It won't gonna change. But theta 2 is variable. Theta 2 itself is variable. It's going to increase or decrease as long as we give rotation to the link 2. Theta 3 also is variable because this link R3 is going to rotate. So this angle is going to change. So it means that theta 3 should be variable. How about theta 4? It should be constant because this link, it won't gonna rotate. There is a fixed link that all the time horizontal that is set up between O and B. Make sense? So for this problem, we do have 4 variables as already given here. Then your objective is just to set up the loop closure equation for this mechanism. We do have R1, R2 go in the same direction and R3 and R4 go in the opposite directions. So we're gonna end up with the loop closure equation will be the R1 vector plus the R2 vector equal the R3 vector plus the R4 vector, and depending we have only 2 unknowns, so we can do position analysis, then differentiate this equation with respect to the time once to end up with the velocity equation, another time to end up with the acceleration based on these variable parameters. Make sense? Just keep going with the conventional procedure that we explained before and we practiced before for the position, velocity, and acceleration analysis for these mechanisms. Make sense?